Okay, now let's take a look at human impacts to these freshwater ecosystems specifically. So that's what we're going to look at. I think we're a little bit out of order on your notes, but you'll be able to find it. We still have to talk about wetlands, but that goes directly into human impacts, and so I've just lumped that together in this lecture. Your book does cover a couple case studies, most specifically the case study on Hurricane Katrina and what humans did to help exacerbate those problems and make them worse. So if we look at the title here, Dams, Deltas, Wetlands, Hurricanes in New Orleans, that gives you an idea of what we're going to be talking about. To start out with, Louisiana has an amazing coastal delta system. We also have mangrove forests along, again, the Florida borders, coastline. Both of these act as coastal wetlands. They're natural protection against storms. A storm does its damage by transferring energy, and if we have a way to absorb that energy, then we can dissipate those problems. And a coastal delta, coastal wetland, is a perfect way to protect from the violence and the energy of the storm. And so what we see with New Orleans and what we see in Louisiana is a significant reduction in the coastal delta over time. What we should be seeing is a buildup of delta because over time more silt and sediment is deposited at the mouth of the river. But that's not been the case. Because of dams and levees, we've reduced the sediments that are accumulating, and instead the tides are eating away at the coastal deltas in the Louisiana coastline. Again, if you've ever been to Louisiana, we're not talking about beaches like you got in Florida, like you've got in Texas, like you've got in California. You have instead a marshy coastal wetland. And so when you have put up those dams and levees, the sediment builds up behind them and does not come through and is not able to help build up that delta, which is, again, our support system against nature. And so we do have this problem then that when Hurricane Katrina came in, there was less protection due to nature. Not only have we stopped building the deltas, we had actually helped to make the delta disappear faster because, again, that tidal action is going to have the energy to eat away and chip away at that. So back in 2005, August 29th, Hurricane Katrina makes landfall, and it was an incredibly devastating occurrence, and you have probably seen and heard about it on the news. But one of the things that made it even worse is that New Orleans sits below sea level. It's one of the reasons why in New Orleans they have quite often have their graves above ground in tombs because they learned a long time ago that if they buried the dead, the caskets would start floating after a major flood because they were below sea level. And so you have this issue with land built below sea level and an area that is capable of being inundated by a hurricane. So here are some pictures looking at the destruction. By now we're talking 7 years ago, so you guys would have been fairly young. This is still very, very fresh in my memory. But again, these areas were supposed to be protected by the levee system, but it might have turned out that the levees, not only did they fail and they couldn't hold back the water, but even before that, when they were functioning properly, they were keeping the silt and sediment from building up on the outskirts of the coastline where the delta would be forming. This is an interesting picture that shows us a projection if the sea level rises not quite a meter. So we're talking about obviously further down the line, but you can see where New Orleans is and that it would be completely submerged with just this little bit of an increase. And so New Orleans is right here in this area. This is Lake Pontchartrain. But what you can see again is that this whole coastline of Louisiana it's a marshy wetland area. It is not that far above sea level. It is just deposited silt and sediment. And again, most of this is because of the Mississippi River and where it runs. So it runs down, making this border right in here, and then it starts to run out. It does have a couple splits in it. And if you watch those alligator hunting shows, some of those things might sound familiar to you. That just went all the way back for me. Okay, so wetlands. That's an example of a coastal wetland, but our inland wetlands are sponges for us as well, and they can help reduce our flooding potentials. So inland wetlands, lands that are covered with water all or part of the year. This came up on the free response questions last year on the exam, and my kids came back and said, "What's a wetland?" I said, "It's got to be wet part of the year." They said, "That's it?" That's it. A wetland has water part or all of the year. It doesn't matter how much. It's just covered with water at some point. So you've got marshes and swamps, and how do you tell the difference between the two? A marsh, it's grass, reeds, and few trees. A swamp is trees and shrubs. Swamps look spookier because you can't see around the corner. Marshes, they're a little bit deceiving because you think, oh, look, it's just grass, and then all of a sudden you're knee deep in water. Prairie potholes. I mentioned this before. This is an area you're going to see it a lot more up north because of where the ice age extended down. But they're just little divots that are created in otherwise some pretty flat lands. And so after a big rain, they'll fill up with water. They'll stay with water in them for maybe a month, maybe less, and then that water will eventually evaporate. It's just a little pothole in the middle of the prairie, but you're going to find organisms that find a lot of nourishment there. You even have some really cool adaptations where frogs might be able to lay their eggs, and their eggs can actually withstand an amount of time without the water, so that the next wet season they will come back, and a population will resurface. Floodplains are also areas that we have inland wetlands. Floodplain, something we're familiar with here. After that, basically it's called a 100-year flood. It's a flood that's not supposed to happen except every 100 years. And the best example I can give you of a floodplain is if you're driving over the Yellow River on Five Forks, where there's the Baptist church off to one side. The Yellow River has a pretty wide path that it could take up. And in fact, when we had that flooding, it was pretty much taking up that entire area, what looks like a play yard for the church youth group. That would be an example of a floodplain. And the Arctic tundra in summer is also an inland wetland. During the winter, it's frozen. We've seen ice road truckers. We know what they're going over. But in the summer, that ice melts and the tundra is like a giant sponge. So we don't think of it necessarily as being wet, but if you stepped foot out there, you'd be pretty soggy. So it is a spongy, marshy area. Why are they so important? Because they are going to give us, again, those ecological services, that thing that we can't put a price tag on, and some things that we can, some economic services. They filter and degrade toxic wastes. In fact, there's been a lot of research done on how we can use wetlands as a way to treat sewage water instead of using taxpayer money to do it. They can reduce flooding and erosion. Again, a wetland is a very, very absorbent area. It's like a wet sponge. Wet sponges can pick up a lot more than a dry sponge. So a wetland, the soil is already ready to hold on to moisture. They help replenish streams and recharge groundwater aquifers. It's a place that the water can sit for a while, which lets it infiltrate. It lets it get down into the groundwater. And hopefully you guys remember that image that showed us that when we take out groundwater, we're taking out from the streams as well, because we lower the water table. So vice versa, if we let the groundwater recharge, then we also let the streams recharge. They are very important for biodiversity. These inland wetlands are sometimes the only places that migratory birds will stop, and we have seen dramatic decreases in things like the whooping crane because of their inland wetlands being taken away. The biggest culprit is agriculture. You're talking about those prairie potholes. You want to fill them in as a farmer so that you can just get your tractor over the whole thing, but that can take away some really important habitats. Food and timber, something else that comes from inland wetlands. There's a lot of swamps that we can get, especially that timber out of. And they also become good recreation areas. So again, what are humans doing? And we've already been talking about this as we talked about the Hurricane Katrina situation in that case study. But again, when we build dams and canals, levees onto rivers, we're altering and destroying habitats. Also, any of those things are reducing the functioning of the wetland. We're preventing the silt and sediment from getting where it needs to go. Some of that is nutrient impacts, some of that is actually physical buildup from the elements. And so when we decide where nature is going to dump its extra and its excess, we are changing what nature had in mind. Impact of pollutants from cities and farms on rivers. We see a huge amount of eutrophication because of how we treat our land, and we're going to explore that further in the case study that you do at the beginning of next week. And when we drain our wetlands, we see an increase in flooding and an increase in drought. Again, we're severely disrupting the water cycle when we do these things. And so it impacts us in the long run adversely. So we might think that we're getting something out of it by draining the wetlands for an extra bit of farmland, but in the end, the floods and the drought could destroy more of the crops than that prairie pothole would have prevented you from growing in the first place. So again, in the United States, I already mentioned that the biggest losses for inland wetlands have been from agriculture. 80% of the wetlands we've lost have been from agriculture. The most famous example of losing an inland wetland, though, is probably Disney World. When Walt Disney bought that land over by Orlando, it was essentially a swampy orange grove. And what he was able to do was to dig parts of it out to make the lakes, and he would use that sediment to fill in where he wanted to build the actual parts of his theme park. But again, agriculture by far and away the biggest impact. Then we go with mining, forestry, oil and gas extraction, highways, and urban development. But again, all those are just going to make up 20%. We do see a lot of what we call mitigation going on now for wetlands, especially in areas like Florida where they do not have very high elevations, so they're prone to flooding hazards. And what you'll see is that anytime you build a large mass of concrete building, whatever it is that can't absorb water, they have to build a mitigation wetland. And it's essentially just an area for water runoff to go so that it's held and is not immediately released to the streams, as that would increase flooding hazards. And that is the end of freshwater. The last part of Chapter 8 to deal with is the marine ecosystems.